Good morning. So class, let us welcome our day with numerous ideas, knowledge about how work done by forces. So lend me your ears. But before I forget, let me ask you, what did you do when you wake up early this morning? Have you heard adults say, I'm so tired from working on the computer all day? Or, all the paperwork I had to do today drained my energy. In this scientific sense, when work is really done, or does the amount of work that one can do relate to one's power and energy? Or how can we do a lot of work together? Okay, class, let us find out as we journey together in this lesson and discover the relationship of work. As we progress in this lesson, always remember to address the question, how can a lot of work be done? So for our objectives, let us define work and energy. Identify situation in which work is done and which no work is done. Differentiate potential and kinetic power. Relate speed and position of object to the amount of energy possessed by a body. Apply the concepts of work and energy in real-life situation. So, have you tried wishing a certain task can be done easily or better yet, quickly? Have you ever wished you can pull off a task at much lesser time? Let us find out the possibility of this. Meanwhile, let us find out if we have common understanding of what one of the important terms in this unit mean, and that is work. So let's begin with the activity below. Okay, so study the pictures below. Identify which situations show the work is done by clicking on the box found before its choice. Write your explanation on the space below the choices. Okay, I will give you 5 seconds to do this. Okay, so let's proceed. So we have here another activity. This is a continuation. Okay, so now process question. What will be your basis in choosing a situation where work is done? When is your work really done? And what are the factors affecting the amount of work we do? And the last, how can a lot of work be done? Okay, so as we go along with this unit, put a check mark before its competency as soon as you become confident about the described concept or skill. So try to check the box on the left side if ever you are already confident. So 1. Identify situation in which work is done and in which no work is done. Then, second, describe how work is related to power and energy. Then, third, differentiate potential and kinetic energy. Then, relate speed and position of object to the amount of energy possessed by a body. Then, infer the amount of work done based on the energy possessed by a body. Okay, class, I hope it is clear. So, in the first 3 units of the physics classroom, we utilized the Newton's law to analyze the motion of object. Force and mass information were used to determine the acceleration of an object. Acceleration information was subsequently used to determine information about the velocity or displacement of an object after a given period of time. So in this manner, Newton's law serves as the useful model for analyzing motion and making predictions about the final state of an object's motion. In this unit, an entirely different model will be used to analyze the motion of objects. So motion will be approached from the perspective of work and energy. So the effect that work has upon the energy of an object will be investigated. So the resulting velocity and or the height of an object can then be predicted from energy information. So in order to understand this work-energy approach to the analysis of motion, it is important to first have a solid understanding of a few basic terms. So, in this lesson, we will focus on the definition and meanings of the terms as work, mechanical energy, potential energy, kinetic energy, and power. Now, what is a work? Okay, so in physics, work is an abstract idea related to energy. When work is done, it is accompanied by change in energy. When work is done by an object, it loses energy. And when work is done on an object, it gains energy. Okay, so what then is work? So it is the mechanical transfer of energy to or from the system by the pushes and pull of external forces. So, again, it is the product of force and distance and the same direction of the force. Now, try to look at this situation. So, you have to compare each of the sentences below based on its corresponding pictures. So, first picture, as you observe, what is needed to push a table? And the other picture, what is necessary to be able to lift a load? Okay? So, what is needed to push a table? Then, what happens to the table as it is pushed? Then, in the second picture, what happens to the load as it is lifted? So, these are the things that you are going to answer. So, the definition and mathematics of work is calculating the amount of work done by forces. You have the potential energy, kinetic energy, and the mechanical energy. Okay, class, we will try to explore more on work. So, when a force acts upon an object to cause a displacement of the object, it is said that work was done upon the object. So, there are three key ingredients to work: force, displacement, and the cause. So, in order for a force to qualify as having done work on an object, there must be a displacement and the force must cause the displacement. There are several good examples of work and that can be observed in everyday life. So let us try to look at this. Okay, class, we have here some examples of work that can be observed in everyday life. So, try to look at this situation. A horse pulling a plow through the field. So, this is an example that there is a work done. So, work is done because there is a displacement. So, the moment the horse pulled the plow, then the plow displaced. So, again, this is an example that work is done in this situation. Okay, class. Let's have another example. So read and observe the following pictures and the situation below. A teacher applies a force to a wall and becomes exhausted. Okay. So in this example, the teacher did not do any work at all. Why? Because the wall is not displaced. It is been said that a force must cause a displacement in order for work to be done. So, in this situation, again, there is no work because the wall is not displaced. Okay, we have here another example. A boy falls off from a stair and free falls to the ground. Okay, so this is an example that there is work done. Why? As you can see, there is a force of gravity which acts on the boy that caused the boy to be displaced in a downward direction. So the fall of the boy caused him to be displaced. Okay, so another example. A rocket accelerates through space. Yes, this is an example of work. So there is a force applied here. So the expelled gases push the rocket, which causes the rocket to be displaced through space. So try to answer this activity. Is there a work done? So try to check in the box and justify your answer. So 3 minutes to do this. Okay, so hope you are all done. Now, in this situation where there is work done, if the object you push moves a distance in the direction towards where you are pushing, so as you can see that the displacement is present when the woman pushes the chair and the chair moves towards the direction of its motion. So again, there is work done in this example or in this situation. Okay, so in this situation where there is no work is done, so if the force you exert does not make the object move, so therefore there is no displacement, then there is no work done. Okay, so this situation describes that there is no work is done. Why? Because the force you exert does not make the object move in the same direction as the force the waiter exerted. So if you look at the direction of the motion, it is towards, but the force that the waiter carried the tray remain as it is. So there is no displacement between the tray which was carried by the waiter. And yet, the direction remained as it is. So I hope it is clear now where the work is done or there is no work is done. Now, what is energy? So, energy is the amount transferred to the object that is equal to the work done. Energy, the amount that is transferred to the object that is equal to the work done. So, this describes the direction applied of force and the direction of the motion. Now, there are two types of energy. One is kinetic energy and the other one is potential energy. So, what is kinetic energy? Okay, so the pictures alone describes kinetic energy. Okay, so energy which a body possesses by virtue of being in motion. So, energy in motion, that describes kinetic energy. Okay, so we have here some examples of kinetic energy. Again, kinetic energy possess motion. So when the ball is moving, then there is kinetic energy. So when the bullet is fired, then there is kinetic energy. No kinetic energy when the ball is stationary. No kinetic energy when the bullet inside the gun is just there. Okay, so I hope class it is clear. Okay, now what is potential energy? Potential energy is the opposite of kinetic energy. So, potential energy is described as the energy possessed by a body by virtue of its position relative to others, stresses within itself, electric charge, and other factors. Now, we will try to examine the examples of potential energy. So, as you can see in this illustration, you can simply determine which one describes potential energy. So, the moment when the object does not possess movement, then it is at a state of potential energy. So potential energy transforming into kinetic energy. So once the ball is being thrown, then automatically that is an example of kinetic energy because there is already movement on the object. So there are types of potential energy. So we have the gravitational energy. So try to look at this activity. So in this activity, you were asked if the illustration of a man lifting a box demonstrates work. So in this situation, who is doing work? Is it the table, the box, or the man? So try to look at the picture. Okay, so it is the man who is doing the work on the box. Question: what is the direction of the force exerted by the man on the box? Okay, so it is on the upward position, direction. So what is the direction of the motion? Again, the direction of motion applied by the man on the box is in upward. So we can say that work is done by on the box. Then we can also say that work is done by the man on the box. So the activity expresses or demonstrates that the work is done on the box. So gravitational force is a force that attracts any two objects with mass. We call the gravitational force attractive because it always tries to pull masses together. It never pushes them apart. In fact, every object, including you, is pulling on every other object in the entire universe. So I hope it is also clear. So now, what is elastic potential energy? Elastic potential energy is the energy stored as a result of applying a force to deform an elastic object. So the energy is stored until the force is removed, and the object springs back to its original shape, doing work in the process. So, the deformation could involve compressing, stretching, or twisting the object. So, again, we have some examples here for elastic potential energy. So try to look at the picture. It is very simple to describe elastic potential energy. So the coil spring of a wind-up clock. You have here an archer stretched bow, a bent diving board just before as divers jump, the twisted rubber band which powers a toy airplane or any others. Now, as what I have said, the energy is stored until the force is removed and the object goes back to its original shape, then doing work in the process. So meaning to say that is describing the elastic potential energy. There is already potential energy present in there. So the moment you stretch or you do something on that object, after doing that so, then it will goes back to its original shape. So then that is doing work in the process. So I hope it is clear for the elastic potential energy. So in other words, elastic potential energy is the energy due to changes in the distance between molecules of a body or object. Usually when it is compressed, example, a spring or stretched. You can see that an elastic band or even in animal or human. The movement. Important sources of such energy are muscles and tendons. The moment you move, then that is stretching your muscles and tendons, and that is or that describe elastic potential energy. So class, I hope you understand. So if there is any questions and clarification, then you can do so. You can. So, what factors affect potential and kinetic energy? So, it depends on the object's mass, the gravitational pull when up or down slopes, and the height of the reference point. So, those are the factors that affect potential and kinetic, and which you are to consider. So class, to describe potential and kinetic energy, potential energy is stored energy, energy that is not moving, energy that increases based on position and height, while kinetic energy, it is always energy of motion. So as energy increases, motion also increase. So both potential and kinetic energy transforms into another type of energy. So any questions about potential and kinetic energy class? I hope I am doing the discussion clear. So anyway, if no more question, then you can log into our e-learning site and accomplish your assignment and quiz. So thank you and stay safe. So see you next meeting. So for inquiry, my number is posted. So do not hesitate to call me or to message me at any time.